All right, so here is the second way to calculate density, and this is for objects that are not as nicely shaped so that we can't just simply take the width, height, and length and multiply those together to calculate the volume. This is going to be very hard to do that. This is a rock, all right? And there is another way to calculate density. And let's just make sure we're getting this down here first. All right, so we got to say that density equals mass divided by volume. That has not changed, but the situation certainly has. All right, so let's just back out here. All right, this is the volume that we got to deal with. And we are going to, if we're taking a look at this volume here, we're going to do something called displacement. We're going to do volume by displacement. And this is really hinging on the fact that this is a relationship where, and you don't have to sort of write this down, but I want to draw your attention to this, where 1 centimeter cubed is also equal to 1 milliliter. Now that relationship alone allows us to do this. This is what we call volume by displacement. And I'm going to drag this thing in here just to sort of illustrate what's going on here. There we go. Excuse me. And what we're going to do is we are going to take a look at placing this rock into a container with a certain known amount of water, for example. And let's say that before we put this rock into this water, that the level is at 100 milliliters. It's whatever set volume that you have already, but you can see here 100 milliliters is a measurement of volume. We use it to measure the volume of liquids. So once we put this rock inside of the water, it's going to then increase the volume overall of both the water, but because now the rock is inside of it, that rock will displace a certain amount of water because this rock also has its own volume. And it's this displacement, it's this difference here that we're seeing between the 100 and this new level of 135 milliliters. That 35 milliliters just sort of came up out of nowhere. Well, it didn't. It came because this rock displaced 35 milliliters. And that is the volume of the rock. Now you're saying, well, that's great, but that's in milliliters. Don't forget, this brings us back to this point over here, which is 1 milliliter is equal to 1 centimeter cubed. So that will actually work in our equation up here. The only thing is I would recommend that you stick to the units that you used. But I just think it's important for us to recognize that this relationship allows us to use this method to determine a volume of an object that is not really too friendly to calculate using length, width, and height. So, with that said, let's make use of these numbers that we've got here. So we've got a 300 gram rock, and it has displaced 35 milliliters. Well, how do we know that? If we gotta, let's be on the up and up on this. Let's just really do this right. So the volume is going to be equal to that 135 milliliters that we started off, well, that we ended up with, minus that original, sorry, I'm just trying to move my screen here, minus that original volume of liquid that we started with, which is 100 milliliters, and that is going to equal 35 milliliters. That is the volume of that rock. Now, we can go ahead and start using that, we can now start using that in our equation up here. Here we go. We've got the volume is at 35 milliliters. There it goes. And we said that the mass of the rock was 300 grams. There we go. And let's just put that there. Keep in mind, I am writing down my units because it's really important for us to do that. And let's do the calculation. 300 grams divided by 35 milliliters. I get 8.57. And I'm rounding that off to 2 decimal places there. 8.57, and let's make our units absolutely correct here. Grams per, and because we use milliliters, we're going to stick with milliliters. Grams per milliliters. Now again, that is still a measurement of volume, because basically we can use the and understand this relationship here, that 1 centimeter cubed equals 1 milliliter. So this is really equivalent to grams per centimeters cubed, which was what we were using originally with that last equation. But it certainly can be used here in this case because we use the displacement method to figure out the volume of our rock. That's basically how you do it. And it's calculating volume by displacement of water. All right.